Hello class, and welcome to lesson 3.5, solving problems with vectors. Today we're going to be tying in some things from previous units. So we're going to be tying in trigonometry. We're also going to use some of our geometry skills from the past to help us solve problems involving vectors. Since it's been a while since we've used probably some of our geometry information that might be helpful, I thought it would be wise for our warm-ups to review what we know about some shapes that could be common to us when we take a look at solving these vector problems. So first of all, let's take a look at parallelograms, ladies and gentlemen. Here's a typical parallelogram. Some of the things we should note about a parallelogram is the opposite sides are always equal. The opposite sides are parallel to each other. Okay, and opposite angles are equal to each other. So those two would equal, and these two would equal. Okay. An important thing to remember that the sum of all the interior angles will add up to 360 degrees. Okay? So A plus B plus C plus D equals 360 degrees. Okay? The reason why, ladies and gentlemen, if I could move this, is each triangle is 180, and you see how I moved that resultant in place, and you had two triangles, so two triangles equals 180 plus 180. Which is 360 degrees. Awesome. All right. Angles are supplementary, okay, when they add up to 180 degrees. Okay, so sometimes you may have an angle out here that is not part of our area where we need to solve. However, if we know that this is a straight line, we could solve the interior angle by taking 180 degrees, which is the straight line, and subtracting the angle value we know. So that's called a supplementary angle to find the interior angle. Okay? You may also note that that interior angle, if you think back to geometry, if I follow a pattern, that's the parallel line theorem that creates the F pattern. Okay, so that's another avenue to take a look at here. And the last geometry tidbit we should remember, folks, is that all angles in a triangle equal 180 degrees. Okay, and again, folks, when we take a look at a resultant in a parallelogram, it's going to be the diagonal. Okay, if you've got two vectors, it's going to create the resultant is the adding of two vectors, right? All right, let's use that information to solve some word problems with vectors. Here we go. All right. Since the answers are vectors, you will need to calculate A, the magnitude of the resultant, okay, and B, the direction. So the direction, we're either going to use bearing or true bearing. And in order to find the magnitude, depending on what type of triangle or vectors we create, making a triangle or making a shape, we'll probably be using a lot of trig today. Okay, and again, if we have a 90-degree triangle, then we can use SOHCAHTOA, but if we don't, we're going to be using the cosine law and the sine law. All right, so here's an example. Jacob rides his bike at 18 kilometers per hour for half an hour at a bearing of north 30 degrees east. Then he heads due east, so that's one vector there, then heads east for 45 minutes at 16 kilometers an hour. Draw a diagram for this information. Then calculate the magnitude of the resultant displacement. All right. So the first vector we need to draw, guys, is 30 degrees. Okay? And he is 18 kilometers per hour for half an hour. So what you need to do, folks, is you need to take 18, and because it's half an hour, you got to divide it by 2. Okay? Which will give us 9. Okay? So we're going to start at our start here at the compass, okay? And we know that he's going 30 degrees from northeast. Everybody okay with that? Okay. If you're not sure where the 9 came from, it was half an hour, so you got to divide per hour because that's what his speed is. So you need to make sure you've got same units. All right. The next is he goes, so that's our first vector. Notice that it's got a direction and it's got a magnitude. Okay, and the magnitude is 9, not the 30 degrees that is part of the problem. That's just giving us the direction. Okay, so vector 1's done. Then he heads east, which is easy to draw, for 45 minutes at 16 kilometers an hour. So for 45 minutes, you should note, ladies and gentlemen, that's 3/4 of an hour. So 16 times 3/4 equals 12. So we're going to take that and place that on here. I'm just making sure I've got my vectors on. I'm not trying to change the size of them. I'm just trying to get them. There we go. All right. Then what we need to do is to discover the resultant. Okay, so the resultant is going to be this here. Okay. All right. So what we need to do, folks, is to figure out how do we calculate this interior angle right here. Okay. But what do we know? We already know that we've got 30 degrees here, right here. Okay. If I follow a Z pattern, I know that this is 30 in here too, right? So I've got 30 degrees right where I drew that dot, but I also should know that this is 90 degrees. Okay. So 30 degrees plus 90 degrees gives us 120 degrees. So we need that interior angle, I'll just put it down here so you can see it, to help us solve. Okay? Why do we need that interior angle? Because looking at our triangle, ladies and gentlemen, we want to get the resultant, which is the dotted line, and it's best to have the opposite angle. Okay, in this case, we would have to use trigonometry, and we would have a side angle side or a contained angle, which means we would use cosine law to solve this. Okay, we'll do that on the second page, so we're still sticking with this problem. Just going to take it to the next page. All right, so that same diagram, folks, we just need to get our resultant. Okay, I've just narrowed in the triangle we're focusing on. And we're going to find r. So r squared, again, pull out your trigonometry, equals 9 squared plus 12 squared, subtract 2 times 9 times 12 times cos of that given angle, 120 degrees. Now be careful, folks. Make sure your calculator is in degree mode. It's probably been a while since we've looked at that. Okay, do some simplifications here. You're going to get r squared equals 333. Okay, remember you have to get r by itself, so r equals the square root, just in case people forget how to do that. So resultant equals 18.248. Okay, therefore the magnitude of the resultant is 18.25 kilometers per hour. Okay? Everybody okay with that? All right. So far, so good? Okay. Second part we need to do is determine the bearing. So first of all, we've got the magnitude. So that's only one part of the vector. On the next page, we're going to actually do the bearing of the resultant, okay? So the bearing is your direction, okay? So what do we already know, folks? We already know that we've got, we need to find this kind of angle in here, okay? So that's what we're trying to find. We already know part of it's 30, but we don't know this other part, this other interior angle right here where I'm going to put this red dot. We need to find that angle. So what we need to do is realize from part B what information we found. We actually found the measurement of the resultant, which is 18.25. Notice now, folks, if we go back to our trig, we have a match. So we can use this match to help us find this angle because we know the opposite side here. So we are going to use the sine law. Okay, so we're going to say sine of whatever angle we're trying to find, theta, which is this one right here in the dot, divided by its measurement, which is 12, equals the sine of the angle we know, which is 120 degrees, divided by the measurement of that, which is 18.25. Remember that we go sine theta equals the opposite cross, which is 12 sine 120 degrees, divided by what you would normally multiply it by to isolate it. And then remember, folks, that we're finding the angle, so we have to use the inverse of this, okay? So again, your calculator does the work for you. You just have to set it up correctly. All right, so plug it in. Plug it in, ladies and gentlemen, and you notice that it equals 34.7 roughly, so let's say approximately 35. We're not quite done yet because this is just that interior angle right here. So in order to find the bearing, folks, that is going to be 30 degrees, which we already know, plus the 35 degrees, okay? So therefore, the bearing, sorry guys, so the bearing of 065, okay? Okay, or you could say north 65 degrees east, okay? So to finish this question accurately, I'm just running out of room, folks. We're going to say, therefore, the resultant has a magnitude of 18.25 kilometers per hour at north 65 degrees east. Just make sure you have both components, and again, you've got to use trig to help us get the magnitude and the bearing. Here's tonight's homework, page 58-59, numbers 1A, 1B, 3, 11, and 16. Have a great day, and see me if you need any help.